we're going to start, this second live session. Today, to moderate this interesting panel, we have David. He's the CEO from Marinov. Everybody will know him, not only in Canada, not only in Quebec, but worldwide. And we have, a few key people that he will introduce soon. As for the introduction, we have a very interesting, keynote making the introduction. His name is Axel. He's, the director of this famous Bioplastic News blog. And I'm going to give him the floor right away and pass, the relay, to David to introduce the panel and make sure we have a good and fruitful discussion. Axel, the floor is yours.
Okay. Thank you, Pierre. So my name is Axel Barrett. I'm the chief editor of Bioplastics News. And basically, I started my career as a public and government affairs practitioner, working for companies such as PepsiCo and Nike. And I remember one day I asked a question to someone who was supposed to give me an answer. I asked him what happens to our plastic waste. And he told me the waste is shipped to China. And when I asked him the question, but what do the Chinese do with it? Are they recycling it? Is it done sustainably? He told me, Axel, you have to stop asking questions and you have to trust the system. So 15 years later of trusting the system, there's more plastic in the ocean than there are fish. So today, let me say that plastic, I think, is the most sustainable material that we have. However, the end-of-life options are its Achilles heel. And there's also a second challenge. It's the sourcing, the feedstock. So bioplastics brings, and I'm not going to say a solution, but brings alternative options to those 2 points. So let me talk about the feedstock. So historically, we've been making plastic from fossil-based feedstock. However, in 1500s before Christ, the Mesoamerican cultures were already using natural latex and rubber to make their clothes and containers waterproof. Today, I think, and also one of the first man-made polymer was celluloid, which is made with cellulose. So today, the fossil-based feedstock is pointed with the finger as being the evil of our society. And I don't completely agree with it. And the reason is that the difference between fossil-based carbon and bio-based carbon is not so big, because basically both come from fauna and flora. So when you take crude oil, initially it was plants and animals millions of years ago. And today when we use bio-based feedstock, it also comes from the fauna and the flora. Not many people know that we can also make bioplastic from animal content, such as chitin and chitosan, or used cooking oils, which are animal fats, but also things like blood from the slaughterhouses. So when they try to do a witch hunting against fossil-based feedstock, we should understand that the carbon from fossil origin or bio-based origin, there's no difference. The only difference that there is age. So you can only measure this through carbon dating. So some people tell me that it's possible to replace fossil-based feedstock with bio-based feedstock. I think there's a problem in the equation. It's volume. So every day we produce 90 million barrels of crude oil. So that's around 14 billion liters of crude oil. So my question is, where are we going to get enough bio-based feedstock to replace that? And you have to know that approximately 5 to 8% is for plastic and 5 to 8% is for petrochemicals. So the answer to this question, where we're going to get that bio-based feedstock in big quantities enough, is in fact the Achilles heel of bio-based feedstock, because the answer is intensive agriculture. So what is intensive agriculture? Well, first of all, it's deforestation. Then it's monocultures. Then it's pesticides. And it's also fertilizers. And fertilizers are usually made with nitrogen and phosphate. And that causes the excessive use of fertilizer, causes the degradation of the quality of the soil. So the fertilizers are not only creating a problem for the soil, but they are also creating a problem for the marine environment. You've probably heard of the concept of eutrophication. So eutrophication, to make a long story short, is because of those fertilizers, algae grow on the surface of the water. There's no sunlight that can go through that algae, so there's not enough photosynthesis, not enough oxygen, so all the animals are dying. So you have the concept, for instance, of marine dead zone in America, but also everywhere on the planet. So that's the first problem of the bio-based feedstock. It's intensive agriculture. The second problem relates to human rights. Let me give you an example. In Belgium, we use biofuel. The biofuel comes from sugarcane from Peru. So a couple of years ago, Europe and the Peruvian government made or created incentives to attract industry, the sugarcane industry. So the government of Peru gave abandoned lands to the sugarcane industry to grow plantations. A couple of months ago, there was a report by Oxfam that said that those lands were not abandoned. They were taken away to local communities. So you have to understand that those local communities lost everything. They lost their houses, they lost their work, they lost their food, and they lost their dignity. That's one example. Another example comes from the palm oil industry in Indonesia. There are stories about NGOs where you have 16-year-old girls being raped repeatedly by the owners of the plantations. And these girls are afraid to testify or to make a complaint because they are afraid to lose their job. And you have to understand that for these girls, the job, it's really important. Sometimes they are the third generation women working on those plantations. So their grandmother started, their mother started, and they are also working there. And then we have stories about women who are pregnant and who are losing their baby because of the heavy workload. And other examples also include women who are working for free to help their husband reach their daily target of work. So you see, nothing is perfect. So towards the future, we have to be careful. If we're going to scale up bio-based feedstock, we need to be really, really aware of those two problems, intensive agriculture and the human rights. And let me just finish by saying one sentence. I think we cannot build a green paradise on a human cemetery. And we cannot build a human paradise on a green cemetery. Ladies and gentlemen, thank you for listening to my presentation, and I give back the floor to the other speakers.
Thank you, Axel, for this very, I would say, interesting, introduction, which address, some of the key issues of the future feedstock, development. And so now we're going to enter, the discussion. And David, maybe, well, not maybe, I'm going to give you the floor, and so you can start, interviewing your panelists. Thank you.
Thank you, Pierre. Thank you, Axel. Today we'll speak at this current panel. We'll speak about some of the issues that Mr. Barrett just raised, important issues. I think that in the past 50 years or so, the plastic industry has evolved greatly, and we have to make sure that within the move that we're making, we're currently towards bioplastics, that we avoid the same errors and that we avoid the same problems that were developed actually in the past 100 years of developing thermoplastics, oil-based thermoplastics. I'd like to introduce you the three panelists today. Joining us, I will begin with Lisa Bolton, Senior Program Manager at Nestlé, based in Switzerland. Mr. Jason Cole, Executive Vice President for Innovation at C Combinator. They have both two companies, actually two plants based in Puerto Rico and Mexico, currently based in London, and Mrs. Helen Tibiros, CEO and Senior Managing Partner at We Grow Green Tech USA, currently joining us from California. First, I would like our panelists to introduce themselves in more details. So can I go with Helen?
Sure. So my initial background is I have a doctoral degree in WE. I worked in Technology Corporation for 25 plus years. And 5 years ago, switched to green technology. Being in Silicon Valley, I observed starting to work with a lot of startups, and what I've observed in terms of green technologies is clearly at that point, the wave was not there yet. I mean, in USA, for example, green technology, it was funny. The perception was more being a tree hugger than really like a clear business objective, right? And if you see in the last 4 to 5 years, a huge amount of change has happened in that space. So during these 5 years, I specialized in a lot of areas. One, decarbonization is one. I'm currently working with a company on a solution to remove CO2 and also air pollutant using a biomimicry-based application. I also worked in advanced materials, such as composite material. I work in waste. The waste market is a very large one, and it's interesting because it feeds into the plastic problem that we have, because if you think about the problem we have today, I think the future is probably going to be a hybrid compound of solution. One, to make our existing infrastructure ecosystem more efficient. And it's true for plastic, right? It's true for carbon and air pollution. And new innovation that we're going to be placing, but are more like mid-term to long-term strategy. So in terms of bioplastic, I think I've worked with quite a few companies, more on the business development side. So I think later in this, I'll be happy to share some of the experience that I had, some of the adoption bottlenecks that this startup are facing. And that's it.
I would also go with Lisa Bolton.
Yes, hello, and thank you very much for inviting me to speak here with you today. So, Lisa Bolton, I'm actually the program manager for what we call the Greenhouse Gas Performance System and ESG Portfolio Solutions here at Nestlé. So over the last, I actually have a background more in IT and program project management, but 2 years ago, I did a certification with Cambridge on sustainable business, and it was just perfect timing because the momentum within Nestlé was really kicked off in the last 2 years around all of these different sustainability topics. So I came in at just the right point to be able to lead the program on analyzing and reporting on our global CO2 emissions across the organization, as well as implementing a solution to be able to track all of the ESG related projects. So this is our packaging commitments, water regeneration, our greenhouse gas emissions, responsible sourcing, regenerative agriculture, all in one place. So for me, it's perfect because it gives me this global view across all of the different ESG related projects that we're working on. In terms of the seaweed, the link into seaweed, so through the certification I did with Cambridge, I started to get very interested in the agriculture point of view and how agriculture and food systems were contributing. And from there, it's a natural journey into seaweed. So I started to look within Nestlé what we were doing in this space, and realized that there were already pockets of in R&D, particularly in areas like pet food and agriculture. We were already starting to look at different seaweed solutions. So I set up a seaweed focus group within the organization, pulling in all of these different parties around R&D. So as I say, with food, ingredients, new product development, agriculture, methane reduction, packaging, so all of the different interested parties. So we meet now monthly, try to push the agenda forwards, look at different solutions, bring in external speakers, and this is why I was able to meet Pierre and get involved in this this conference today. So thank you very much.
Thanks, Lisa. I would afterwards go with Jason Cole.
Great. Thank you, David. Yeah, so I'm Jason Cole. I'm the head of innovation for C Combinator. We are a seaweed-focused startup operating in Mexico and Puerto Rico primarily to work on the making value-added products from the sargassum bloom that's happening throughout the Caribbean. So we are working. We're really kind of trying to take an integrated biorefinery approach to the processing. We're launching a biostimulant, and we've made from the sargassum, and we've also developed a cosmetics emulsifier and we're about to launch in the next few months a seaweed-based leather, which will be quite an interesting product. And it's kind of funny. Like the rest of the panelists, I am also a refugee from the technology space. I spent 20 years in educational technology, and that's what my doctorate's in. Before making the switch over to first to climate solutions, and then specifically seaweed as a climate solution. And my job now is exploring the technology landscape and trying to understand where our future opportunities are to make both to make carbon impact and to provide a commercial opportunity for communities that are inundated by sargassum.
And myself, David Courtemanche, will be the moderator today for this panel. I am the general manager of Marinov. We're applied industrial research center based in Canada. Our main goal is to collect the needs of the buyers, the users of the different products that we extract from the sea, and to find solutions to better extract, better transform, better process, and better use every molecule that gets extracted from the sea or produced from the sea. And myself, I'm also an IT refugee, as you would say. I've been active with two businesses in ITs before I joined Fisheries and Oceans Canada for 14 years, and afterwards moved to Marinov for about 6 years. So today will be a very interesting topic. Plastics are everywhere. We produce billions of kilograms of plastic every week, every month, every year. The first thing that we currently don't address that much is to reduce the use of plastics and to do a better use and to go the full cycle of plastics. To at the end of life of plastic, what can we do with them? So we'll let go of these aspects that will be covered in other panels during this meeting and other meetings. And we'll focus on the bioplastic, biosourced plastics, where we at now in the developing and using of bioplastics. I will begin with one question. What's the main difference, or what are the difference between a bio-based plastic or oil-based plastic? Are there similarities? Are there differences in their properties? Can we use one or the other without adaptation, or what's your view on this one?
I'll go first if you don't mind. I mean, I think it depends on your definition of a bioplastic. So we can take ethanol and make polyethylene. We can take bio-based ethanol and make polyethylene, which is completely indistinguishable from fossil-based ethylene, all the way up to an alginate-based reinforced plastic, which behaves very differently from a traditional plastic. But at that at the alginate end of the scale, it's the plastic it decomposes, right? It decomposes easily. At the other end of the scale with polyethylene, we have the same end of life issue, right, as we do now with fossil-based plastics. So I think it depends on the range that's possible is enormous, and I think it just depends on how we're going to define. Is it bio input, or is it just bio input? At which point you can make anything, or is it a specific category where we're saying like, okay, it also has to be biodegradable as well as a bio input.
If I can add to that, and if you look at the bioplastic map, right, if you try to categorize all the different bioplastic available, you can actually have two scale. One will be like the bio-based, right, and one is it truly biodegradable? Because there's an interesting platform for the people in the audience called Ubuntu that they approached me a few years ago. They grow extremely large, and you can find a lot of bioplastic solution. And what I've seen by working with quite a few startups and studying that space is there's a huge amount of variation. because you have this two dimension, right? So not every bio-based plastic is biodegradable. And not every biodegradable plastic is necessarily coming from a true biomass approach, right? If you look into the bio-based, biodegradable, you will find PLA, PHA, PBS. All of those, some stands for polyalkylic acid, biodegradable polymers. All of those variations, right, are potentially offering interesting alternatives to plastic. But then I think when you have to start looking at is these other parameters in terms of comparing plastic to bioplastic. One is consumer adoption. Is it really something in terms of overall use that can compete with plastic, not only in terms of flexibility, but in terms of temperature, in terms of pressure, all these requirements that anybody that wants to use plastic needs to meet. So that's a huge amount of constraint that people that are developing bioplastic need to meet. And the other one, which is really interesting, is does it fit into a circular model? Because what we observed, and I'm more familiar with United States and in Europe, is a lack of circularity for bioplastic. Because some of the bioplastic cannot be part of a waste system. Because there is a currently recycle system in place for landfill plastic, right? And you cannot put bioplastic in either of those. Because the bioplastic, if you put that in landfill, create other side effects that are not wished, but you cannot put it in plastic. So I think when you start thinking about a bioplastic solution to be fully circular, right, it needs to be fully compostable and it needs to be part of a system. And as currently, for example, where I live, there's so many norms that you cannot put bioplastic in compost. So then you start thinking, oh, you have to put it in landfill, and then you're introducing another problem. So it's a very complicated issue when you push a bioplastic. And now again, it depends in the geographic area where you live, because it's not only based on the composition, the material, the source. It's also based on can you recycle it, can you be adopted by consumer, and I've seen so many bioplastic solutions just in terms of being able to scale in production. Right, I think Axel make a very good point. If you start using PLA, for example, type of bioplastic that are based, for example, on corn or sugarcane, is it going to be sustainable when we're facing maybe food crisis in 5 to 10 years, when we don't have that much land available anymore for growth, right? So I think all of this is parameters that you have to take into account when you look at the scaling of a bioplastic.
And perhaps I can just, first of all, completely support what Helen and Jason have just said there. But to add in, so I think you have the functional comparisons. So looking at from a Nestle point of view, is it suitable for food grade? So you have all of the functional comparison, and then on top, as Helen mentioned, then all of the either co-benefits or co-risks that are coming with it as well. So when you're talking about all the different variants, what's their CO2 impact? Is it responsibly sourced? The social impact, so that all of the water usage, so all of those co-benefits or co-costs that are coming with it as well. So it's very clear that they're not all equal, and it's starting to become, all of those different elements are starting to become more and more important.
That's very interesting angle. We see we've seen in the last 3 or 4 years actually a very strong will to integrate these aspects when we think of developing the bioplastic industry. Whereas with the normal or traditional oil-based plastics, we develop, we use, and afterwards we think, okay, what are the impacts and how can we mitigate them? So by developing the whole industry, bioplastic industry, integrating these things at the start, so the production, social impacts, environmental impacts during the production, use, and end of use, I think we're probably heading in a very good way. There's something that's been mentioned in this panel and the previous one, in the opening remarks of the BioMarine convention. Is there a need for a label to establish, okay, this is a bioplastic, and this is it meets different goals, different objectives throughout the whole cycle?
I think there is already some existing standard that I'm aware of in terms of to help industries, to help large corporations in terms of biodegradability, bio-based. There's ISO. I'm aware of 2 or 3 of them. I think that's when it's interesting, because when you look, a few years ago, everybody went into creating a bio, because everybody's so passionate about it, right? So let's create a bioplastic solution. And when you actually start looking into do they fit with this standard, most of them don't. So I don't know if it's, my answer is type of what I know as of today. Is there a need to further expand and to consolidate? Probably. There is already some standard though, because I've applied some of them, and when I was looking for solution, that's some of the criteria that I use.
Case, maybe the large bodies of financing could use some of these criteria to fund projects or development of businesses. You
Correct.
need these basics before we can fund your project, and maybe we could probably force, or at least, I would say force the development of better plastics. In fact. In your opinion, why are biopolymers still niche products, or in the global market currently? Is that we still are facing issues or challenges with production, public acceptance, and business acceptance of a new types of plastics?
If I can quickly comment to that, I'm not trying to I have a lot of experience on this because I faced so much resistance. It's cost. Most of it is cost, because if you look at plastic when it was introduced, cost was high, but as any new solution, as you scale it, right, the costs go down and it got massively adopted. So the challenge you see with bioplastic, even if you can find a material source that is affordable, it's always a cost, because as of today, it's still a niche, right? You still have to find the perfect technology, perfect requirement that fits with customer need. And we find a couple of companies like this, but the production is still at a very low level. So you can't compete with the cost of plastics that has been around for so many years. And when you look specifically for food corporation, when really the margin is very low and everything counts, introducing, for example, a solution that sometimes can be 5x more expensive in terms of packaging, unless you're being subsidized, unless you find additional way or there is tax credit or benefit, right, to happen, then that's been the challenge that a lot of these corporations have faced. A lot of these new startup solution or people that are trying to launch the product.
I can just add to that as well from what we're seeing here at Nestlé. So some of you may know there was a $2 billion fund that was released a couple of years ago to stimulate the recycled plastic market, because, as you know, the cost per unit's cheaper still for virgin plastic products than recycled. So the funding is there, but it was focused more on these recycled materials. There is also the investment, around 250 million investment on alternative packaging, so the sort of biopackaging that we're talking about here today, through the Packaging Institute. So there is some funding there, and there is a willingness to pay premiums, obviously to a certain extent, to pay premiums for these either the recycled, recyclable, compostable material, alternative packaging materials. We're also focusing on our greenhouse gas emissions. So where we can see that there's an opportunity to reduce our overall emissions through packaging as well. This is obviously an additional incentive to invest. But what we've seen in discussions with different organizations is partly the technology in terms of the food grade, the quality for the sort of packaging that we're looking at, and then having that technology available at scale as well. So I think we need to we absolutely need to move together. So Nestlé we've set up the Packaging Institute, but we're not a packaging company, so we are looking for the suppliers to be able to provide that to us at scale. with a reasonable price point, taking into account that there are these premiums for certain types of packaging and for these greenhouse gas reductions. So I think there is a potential. As you said, Helen, once you get that going at scale, then the price drops once you get into that anyway. So there is that initial kickstart available. But from what I'm seeing, it is more around the specific requirements for food grade packaging, whether it's just the sort of the coatings, the filters over the top of other recycled materials, or the actual full packaging itself, and then to have that available at scale in a sustainable way, with the research behind, for example, to confirm the CO2 reductions or to confirm the usage in terms of sustainability. So I think all of it is starting, it needs to move together, and organizations like Nestle need to be prepared to support that as it goes forwards. But it feels like at the moment we've got a number of different challenges.
I totally agree, Lisa. And I think the other thing that I've seen is the US hasn't been to the same point that Europe or South Korea, for example, in terms of passing regulation against plastic. That will actually also entice people to move. But another interesting aspect is consumer. So I work with this Amazon platform to bring a sustainability part of the overall CP consumer product good product. So what we're seeing when you study what people buy, it's interesting how pricing is still right the main motivation, but as you go with younger generation, pricing is becoming less of a factor. And being ethnically sourced, better packaging, being green, is really starting to motivate the consumer. And so if you're starting to kind of see all these trends converging, right, I mean, it gives you hope for a future when we can start pushing better solutions.
Yeah, and David, I'm the silent joker, and sometimes, I can't refrain, from jumping in, because, the cost is really important. And I know that we all think that this is an emerging trend, but it's not anymore. It's a fast-growing trend. And I know the hard work that Jason is doing to convince, the consumer, the industry, to get into this. But what's really happening is that when you look at the global picture, especially for the seaweed, if you take only the bioplastic, well, it would make sense to say, well, we need to scale up because the price is an issue. But if you integrate, the entire value chain and the extract that you're going to extract, from the seaweed, it's more a valuable compound. Because at each step of the biorefinery process, when we're going to extract something, the co-product and the byproduct becomes a new product. So we can extract the sugar for the bioplastic or the alginate, and then we can still work on getting a higher price for the fucoidins, for the phenol, for the oil, which now is becoming a new trend as well, for extracting H2 from the galactose or from the mannitol. So there are many ways, to approach the seaweed bioplastic value chain, but the bioplastic is one of the byproducts that could have an interest, if you look at integrating the entire value chain. And cost won't be an issue. Remember, the PLA was quite expensive when we started, to develop PLA. And with the scaling up, that is mandatory, because seaweed is not only for bioplastic. You need to keep that in mind as a key point. Seaweed is used in anti-COVID, in antiviral, it's used in biomaterial, it's used in cosmetic, in pharmaceutical, it's used, in texturizing agents, in emulsifiers. It's all over, in the meat industry, in the confectionery, it's all over. So seaweed is pretty much everywhere. We need to grow seaweed. And I'm not mentioning, because I don't want to get into this, the climate effect and the carbon reduction. So it's huge. But also, if you look at nitrate, reduction of pollution, environmental concern, there's nothing compared to seaweed. And when you take the global effect of seaweed, then it's cost efficient. And at least, we know that from an investment point of view, and more people are coming to us, say, well, Pierre, of course, offsetting is very sexy and appealing, but there's much more than that, and we want to start to invest in seaweed. But think about the bioplastic and the feedstock. It's global. We have 66 million square kilometer that could be available for cultivating seaweed. Yeah, we expect to be at 2.3 by 2030 with alligator, but it's nothing. And what about, the sargassum? Jason is working on this. Sargassum is huge. It's a plug in some of the areas, but they want, to transform a plug into an added value compound. So I think that think different, and you see that bioplastic coming from seaweed is a real opportunity, and price won't be an issue very, very long. Sorry for that.
Yeah, no, that's a very, very interesting point of view. What appears also is that we're probably stuck in the catch-22 situation here. We tried to develop bioplastic, biosourced plastics with very high criteria for sustainable criteria, and we put it in competition with oil-based cheap plastics where users don't pay the full cost of using that oil-based plastic. If they were paying the full cost, then probably the price difference would not be that much. Pierre, your opinion is very valuable, as there's additional value to bioplastics. There's the sustainable value, environmental sustainability value added to it. There's also the green image that the companies using bioplastics as wrappings, packaging, that kind of things can gain from, and also the full use of the resource. Some people will say, well, from oil-based plastics, we also use the other fraction of the oil extracted to produce asphalt and that kind of things. But it's, I think, where there's not that many options to avoid, for example, CO2 emissions, is to reduce or stop the extraction of new oil. And that's a no-brainer. There's one solution to the greenhouse gases problem. We have to reduce the amount of oil that we extract.
Well, if I can add something to that, right? Because I have a slightly my vision is an hybrid solution. Yeah, you want to decrease your dependence to fossil fuel or to plastic, but the truth is, if you look in some area, maybe people will switch faster. In some others, it's going to take a while. So I think there's really a need as of today to push new innovation, such as seaweed for bioplastic, such as new type of energy, electrification. But if you start even looking at electrification or renewable energy, we're going to face bottleneck because of the lack of material moving forward. So when we think we're all going to be electric or renewable energy by 2030, this is not true. If you really start looking at the true supply chain, this is more long-term. Mm-hmm. And we have a crucial need for planet right now in terms of decarbonization. So to me, I think looking at solution, push new innovation to reduce our dependence to plastic and to fossil fuel is key. But also, if you think when we introduce plastic or fossil fuel, I give internship to a lot of students, and half of the time they mad at us because I say, why did you push this technology? Why did you push this solution, right? Because they look at, now it's our turn to find a problem. But at the time when we introduced it, with the insight that we had, we saw it was a great improvement. It was a great improvement to coal. Plastic was a great improvement to what we had before. We didn't think about the lack of circularity in this model. So I think today when you look, it's also crucial, just because we have so limited time in front of us. For plastic, maybe we have more, but in terms of CO2, decarbonization, air pollution, methane, right? It's something that is really short term. So I feel there is also clearly a need to basically look at what we have today, this infrastructure, and at least think, how can we make it circular or minimize the impact that they have? And I think for plastic, I think seaweed is probably one of the most exciting solutions, just because if you look at the amount of resource, the circularity of it, the fact that it provides a way to get, it fits into an ocean regenerative system, right? I think it's a very promising solution. But I think if you think globally, right? As far as the amount of plastic that's already in there that needs to be, it takes something like 50 to 400 years to remove plastic. So I think our solution also needs to be taken in account so we can resolve the problem at the larger scale.
Yes.
Yeah.
Jason, on your side, you're involved into production. So what would be the key factors or key issues that you're facing currently to improve the amount of bioplastic, bio-based plastics that we produce, what's the main issues you're facing currently?
Yeah, I think a lot of the issues have already been discussed. I think there's two valleys of death, right? That a lot of companies fall into. The first is like they managed to get the first lab scale product, and they can produce it, and it's good, and it's and then but getting that first customer, right, someone who's going to buy it at 5x the cost, right, of a or more. And then if you manage to get through that valley of death, the second valley of death is the large scale commercialization, right? And getting on that learning curve. How can getting on that learning curve where across industries, if you look at it, every time you double production, you reduce costs by 5 to 7%, right? And if you look at if you look at solar, if you look at wind, they've been on that curve for years, for decades, right? And now finally they're at that point where they are cost competitive with fossil fuels, even including the fact that fossil fuels don't have, like you were saying, Helene, or they don't have to pay, or David, they don't have to pay for their externalities. So how do we and that second valley of death is it's huge, because you can go from being a niche product, but then to talk to a large consumer packaged good companies, you've got to start at 50 tons, right? You've got to start at these enormous numbers that require huge amounts of capital, right? To get that up and running. And there are very few places where you can go to sort of de-risk as you scale. And that's what we're looking at right now. Fortunately, we have in our plastics and our packaging activities, we have a partner. We've partnered up with a really forward-looking cosmetics company who is they're helping us drive the entire process in terms of like taking 3 steps to scale, right? Like small initials, then the next step of scale. Guaranteed offtake agreements at 5 to 6 times the cost of plastic, right now, with looking at a cost curve and that sort of thing. And that's going to be the booster for us. If we can manage to bring it all together, that's going to be the booster for us. But it has to be driven by a visionary company who, and for a cosmetic, by somebody who has the money, who has the vision, and can do the demand pull and deal and absorb those additional costs. The advantage of like being with a cosmetics company is that the cost of packaging is very small compared to the cost of the product. Unfortunately, in the food industry, it's you don't have that same luxury. So for so again, it's also about picking your markets, right? Maybe food's not first. Maybe it's those higher, maybe it's the Tesla model of disruption where you start at the high end and work your way down, rather than starting at the bottom and working your way up.
Great. Fortunately, sitting virtually besides you, we have Lisa from Nestle, a huge corporation that committed to a goal of replacing or using 100% bioplastics for their packaging by 2025. And I think you're definitely right, Jason. We need huge corporations to invest and to try to bridge that gap, that valley of death that many are facing developing a new industry or new product. Lisa, you think that science and technological advances will allow Nestle to meet their goals?
So maybe just a small correction, an important correction there on the commitment. So it's 100% reusable or recyclable packaging by 2025, which actually currently, so the 2020 figure was 88% of all of our packaging already being reusable or recyclable. We're trying to also then increase the recycled content and reduce our virgin plastic by a third by 2025 as well. But within that picture, obviously comes then the bioplastics. And from this point of view, this is where we're working in the institute, the Packaging Institute, to analyse and assess the different new products, new potential solutions that are coming out. I believe one of the audience members here, or a couple of members we've got today from Bezios, who's one of the seaweed-based packaging solutions that we are working with at Nestle. For me, this is really key as part of the suite of solutions. So as Helen mentioned, this is very much a hybrid approach. It's what we call fit for purpose. So where we've got things like some of the pet foods or the coffee, we're looking at some of the reusable containers and the refill systems. So that works very well. In other areas where it's very closely connected with the food grade, so things like the frozen pizzas, for example, then there has to be certain standards, certain type of packaging that suits to that situation. So it varies a lot. I think for our 2025 commitment, this is on track at the moment, and we're confident that we can meet that. But this is just one part of the picture, and we have to consider that we are really starting to look at focusing more on the bigger picture outside of this as well. So let's say that by 2025, all of our packaging is reusable or recyclable. First of all, you have to make sure that the infrastructure is there. As Helen said, in many markets, the infrastructure is not there to recycle some types of packaging. If it is there, consumers have to do it. So we have to get the messaging across, we have to educate, we have to provide on-pack information about how to recycle. We have to, in some way, follow up to make sure that that's happening as well. So this is where the compostable option as well comes in, because if it's not getting recycled, can we make sure that it's available? Can it be home composted? Can it be done in local composting facilities? And then talking about the bigger picture, so we started off quite early with our packaging commitments, and since then we've communicated our net zero targets, so 20% reduction of our CO2 by 2025, 50% by 2030. Packaging contributes towards those targets as well. So what we're seeing is some shifts in packaging are actually showing an increase in emissions. So what we're also looking for are ways, so even if we've moved to recyclable solutions, can we continue to evolve our packaging to also contribute towards our greenhouse gas emissions? We just also released information on regenerative agriculture commitments. We already had our responsible sourcing in place. This whole, it's all connected. And we need to look at we're starting to connect all of those commitments as well and see where we're investing, what's the knock-on effect across the board as well. So I think this will help to drive those decisions. So maybe it's not enough in some areas to have just reusable or recyclable. We have to look at how it's sourced, what the pricing is, what the water usage is. Regenerative agriculture, one of the things which personally frustrates me very much at Nestle is when we're talking about regenerative agriculture, we're talking always about on land, and we're missing half of the picture. And I'm starting to see that's being discussed. We had some representatives from Nestle that were at COP over the last couple of weeks who were involved in some of those discussions, and the ocean view as well for regenerative agriculture. And so for me, it's really about changing the whole system from a vicious cycle to a virtuous cycle. And seaweed solutions in packaging is just one example of that knock-on effect and how that can switch. So it's, I don't know if that answers your question. I think, Pierre. Yeah.
I think that, Lisa, what you're saying is fundamental, because you're sending a strong message, to this developing industry. I mean, it takes a lot of effort, for startups, to be compliant with the existing, standard of the industry. But I keep telling them, keep trying, keep improving. get, together, to improve, the development of this sector is very important. And when I'm listening to you, I say, well, nothing will happen without, companies like Nestle and other large groups, because you are in direct contact with millions, dozens of millions of consumers. You know what is, driving the demand, and you know how to achieve that. And of course, Nestle is a large, big tanker that needs time, to rearrange, the course of its, navigation. But with the scouting unit that the bioplastic and the seaweed bioplastic industry represent, you're going to have, the right bearings, to avoid, to get straight into the reef. So I think that your message is very inspiring and very, I would say, helpful for all the young seaweed bioplastic industry that are listening to you. And I really like that. And I know that it's hard internally, to convince such a big organization, but the job that you're doing is essential, and we need that, Lisa.
Thank you so much. Yeah.
Great. I would follow it with a question. You just mentioned that by thinking of agriculture and sourcing, we're missing half of the picture. As the oceans represent 2/3 of the surface area of the Earth, do you think that moving some of the sourcing or production towards the ocean would be a more sustainable option for bioplastics?
I mean, from my point of view, absolutely. I mean, it has to be done in a respectful, in a sustainable way. But from the organizations that I've talked to over the last year or more, that seems to be at the heart of what they're doing. So where we're trying now to go backwards and work with our farmers on land to try and integrate those regenerative agriculture processes and take things back a step, we can start out like that in the oceans. So for me, that's extremely positive. And you've got the way that the shifting it to the oceans can take the pressure off the land, and then at the same time, some of the outputs of what you're growing in the oceans can be put back in to boost the land production, so replacing chemical fertilizers, etc. Jason, sorry.
And I think to add to that, I work in regenerative agriculture in order to bring a similar concept to, I don't know if some of you are familiar with culture. There is more and more, it's very old. It's something that comes from looking at Aborigine. Then over the last 100 centuries, they developed very intelligent way to better yield by using natural processes. The challenge we see with regenerative agriculture is always linked to money, because farmers have very little room. So starting to implement regenerative agriculture, regenerative farming take a long time. And I think in terms of bioplastic, that's where seaweed is very interesting, because bioplastic, depending on biomass on the land that will require regenerative farming, is going to take some time, or at least I'm talking from my experience in the United States, based on the agriculture have been structured. Switching to seaweed is a much accelerated way to kind of generate bioplastic, just because of the ecosystem you're faced with today.
I wanted to, Lisa made a point about especially about the fertilizers and that sort of thing. I think it's interesting because there's growing evidence that the sargassum bloom is actually a consequence of eutrophication throughout the Caribbean basin. So it's interesting the potential then of using seaweed and seaweed aquaculture to really clean up, like not just avoid nutrient emissions, but actually clean up the nutrient emissions, and like you were saying, Lisa, maybe bring them back to where they started. Here we found this. You can have it back. But just I wish I could do that with the arsenic. But I think there's a strong argument to be made, right, in terms of that eutrophication, that restorative ecology. But I think it's also, I think both Helene and Lisa, you've both brought up the point about circularity, and it will be an interesting challenge for seaweed-based plastics that aren't that are on the more biological end, right, rather than sort of like, rather than, I would say, the biochemical end, right? So like if we're talking like an alginate plastic or something like that, that's not like, oh, I've ripped the seaweed down to its constituent sugars and fermented ethanol, now making ethylene. In that it's not, they're not really recyclable, they are compostable, right? And so when we're looking at targets that say that has to be recyclable, or it has to be recyclable, it has to be circular, as long as the circularity definition, as long as it incorporates like going back to the soil, then that's okay. But there are a lot of definitions out there that will actually make it difficult to introduce a seaweed plastic if it has to be recyclable back into plastic, right? I can recycle it back into carbon, but I can't recycle it back into plastic, and so that's going to be an interesting challenge in some markets. But in other markets, like where we've been looking at markets where there is no recycling infrastructure, just zero. And so having a compostable plastic in those markets and in those applications, like that's going to be your biggest fastest win. And so those are sort of the applications that I think we'll need support on, and we'll need to be able to look at, because we're not going to be able to implement the recycling infrastructure in a lot of areas, in any time that any of us care about.
If I can make a comment, Jason, on your point, I studied the recycling environment in the United States. So people claim big number as far as the amount of plastics that is being recycled. If you look efficiently, you're looking at 10%. Interestingly enough, for example, it comes from very simple step. Like I work with this company called Clean Robotics that is capturing metrics for recycling. So they find out that most plastic bottle, for example, could not be recycled because people toss it with half full, right? So it cannot be recycled. So I think there's a lot of work that still need to be done, because the metrics that sometimes that you see are not real metrics. When you really start looking at the number, there's still a long way to go as far as in plastic, right? Doing something that's efficient. That's why I think introducing solution that could be fully compostable, that could fit into a model where, okay, you can put that in your compost. And like, for example, the seaweed bioplastic is actually a faster solution.
But Hélène, it's very interesting, but just a quick comment. I was last week, I was discussing with a large UK group in distribution and say, well, it's amazing. The packaging is edible, water soluble, compostable. And say, well, Pierre, but it doesn't check our box, because what we're going to do? Because we need to recycle. So we're not prepared for that. So it's also, reinventing, the way we deal with that. Because if you go to a large group and say, well, I'm sorry, I can't use your plastic because it's not recyclable. Say, no, there's no end of life. Oh yeah, but it doesn't check the box. So it's also education and preparing the ground, for this future new disruptive innovation. And this is very important.
I fully agree. And I think when people start understanding it can go in the compost, and you have recycling environment, all these systems that start adopting it, I think it could be such a large, quick adoption, right, to do it that way.
We have 1 minute left. If you were given a magic wand, what would you exert as a power on public policy to make sure that bioplastics are propelled in our world currently? So I would begin with Jason. You have one magic wand.
Full externalities pricing. So that's my, if you're a plastics manufacturer, you've got to pay for the carbon, you've got to pay for disposal. At that point, I think I can compete.
Great. Lisa?
Oh, Jason took my answer. So I will take his answer, and I add on top of that you have on the opposite side, you're rewarded for the co-benefits of the packaging as well.
That's exactly how we go with Lisa. Incentive, because it'd be so hard to penalize fossil fuel company that I think it's probably more efficient to actually give incentive to the people generating bioplastic.
wand was magic, not really.
Yes,
There are lots.
and Pierre, you're given the magic one also. What would be your take?
Well, my wish is that governments get more knowledgeable and do not wait, for the next election, to be reelected. They should, move ahead the time and put some very clever regulation to invite people, to move in the right direction. That will be very helpful. And even in Europe, we're not there yet. And I think that we need to enforce that, and we need you to convince more people to get into this direction.
Great. So full externalities, price, cost. We have incentives and we have regulation. I think with all these three things, I think we can go forward with moving in a better direction, better world. Thanks for that. It was really interesting as a panel. I learned a tremendous amount of things during this session. So thank you all for participating.
Thank you. Thanks very much for joining.
And don't forget to click on the next session, if you want to join, the next interesting, panel. Thank you.
Thank you.
Thank you.
Thanks.
Bye-bye.